Hi guys, in today's video, number 31, we'll modify the data logger scheme for temperatures which we discussed in video number 29. To this scheme, I will add an LCD display necessary for real-time display of data saved on the SD card. The second modification made to the data logger project relates to the use of the Arduino MEGA board, which has more interface ports and much more flash memory, 256 bytes versus the 32 bytes of the Arduino board. To summarize, in this video we will build a new data logger for Type K thermocouples, with microSD storage, a real-time clock RTC, and a 16 by 2 character LCD display. Let's now look at the necessary materials for this project: an Arduino MEGA board, a microSD card reader, an interface for reading the temperature from a MAX 31856 thermocouple, the RTC real-time clock board, and finally, a 16 by 2 character LCD display. Additionally, we also need a one-way switch, 2 LED diodes, 1 green and 1 red, 2 220 ohm resistors and a 10k ohm resistor. So, let's look at the various components: the microSD card reader board, the interface for the MAX 31856, the RTC board, the Arduino MEGA board, the LED diodes, the 3 resistors, the switch, and the 16 by 2 character LCD display. In the simplified scheme, we can see the redirection of all the ports that was done following the switch from the Arduino Uno board to the Arduino MEGA board. Now, let's look at the detailed scheme. We then have the power connections. We then have the switch, to start or stop writing on the SD card. The green LED, to indicate ongoing writing, and the red LED that tells us when the file is open and when it is closed. Then the connections of the RTC, the MAX 31856, the microSD and the display. We still have many free ports, so there are still really many possibilities for interfacing. I won't dwell too much on the scheme, as it has already been described in previous videos. However, remember that all the schemes and sketches can be found in the video description link. Now, let's look at the sketch of this project. So, the first thing we need to do is open a new file and then include all the necessary libraries. In addition to the data logger project done in video number 29, this new library, liquidcrystal.h, is included, which is the library that allows us to use the LCD display. As for the pin correspondences in the various boards, I had to redirect all signals to the ports. In the case of the microSD interface board, the MISO, the MOSI, the SCK, and the SD have been redirected to 50, 51, 52, 53. Similarly, also for the interface with the Type K thermocouple, I redirected all 4 pins. Then here we have the definition of the pins corresponding to the display ports, so RFs, enable, D4, D5, D6 and D7 go on these ports, from 22 to 27. We initialize the liquid crystal object with the correspondence to the pins defined above. This part is identical, it remained unchanged from the project of video 29. Here the LCD is initialized, which is a 16 by 2. Here we check if the SD works correctly. At this other point instead the presence of the file name is checked and, if there is, it is removed, to then create an empty file later. Here instead we initialize the interface for the temperature reading and here we specify the type of thermocouple we are using. Here is another check on possible error conditions, that is the initialization of the RTC, real-time clock. At this point, the current date and time are then saved. The loop begins. From the loop, the position of the switch is checked. If it's in write mode, it creates the file named datalog.txt. An object, now, is created which essentially contains the current date and time. Here now we have one of the 3 write-in blocks. This is the one that provides the write-in to the serial monitor of the date and time. The string, cold junction temp, the temperature of the cold junction, is subsequently printed. From here, the thermocouple temperature and the corresponding value are printed. Here is the string and here is the value. The 2 temperatures are stored in the 2 variables, CJ_value and TC_value. At this point, the write-in to the file begins. The date is printed, the separator character, the time, another separator character, then the value of the cold junction, another separator character, and the temperature of the thermocouple. Through this IF, any error conditions are checked and corresponding messages are printed through serial.println. Here, the last block, which deals with the writing of the temperature, date and time on the LCD display. So we have an LCD.clear that clears the display. An LCD.setCursor at 0, 0 that positions the cursor at the first character of row 0. The data variable is printed, a space is put, the time is printed, then the cursor is positioned on the second line and the string, TC equals, is printed, for thermocouple. Here the temperature value is printed, the degree symbol, and the value in Celsius degrees. After this, a 2-second delay and then the loop starts again. At this point, if we haven't made any mistakes, we can save our project, check it and load it onto the Arduino MEGA. Well, at this point I would say we are done. If you liked the video, remember to give me a like, subscribe to my channel. If you want to receive automatic notifications every time I upload a video, also click on the bell icon. Now I say goodbye and see you next time. Bye and have fun.